welcome all of you to this webinar. Today I give you an introduction into scripting with Python and how to automate debugging or do automated tests together with UDE. And later on I give you also some hints and tricks maybe on how to get certain things done using Python in UDE. And I think that will be very interesting for you, hopefully. So let's get started with a short look at the agenda. Firstly, we go to some basics, so all the things you need to know if you want to script the UDE debugger. Then we take a look at a typical use case of scripting that is, of course, automated testing. So that means without any user interaction with the tool. I will go step by step through a simple example of a Python script which executes such an automated test and which controls the debugger remotely. So meaning without user interaction. And finally, I take a look at our FAQ and also to some of the questions we got in the past about scripting for UDE. And I will provide you some tips and tricks on scripting. So then let's get started. In UDE, the scripting is a feature that we call UDE automation. That is included in every debugger base licenses. So you have no additional costs for using it. As the name says, the purpose of the UDE automation is to automate debugging and testing tasks. This is done by controlling the debugger from another software. This can be a script, or this can also be a third-party software such as a commercial test tool. The heart of the UDE automation is called UDE Object Model, which is an open and flexible software API that provides access to all the debugger functions. So the UDE Object Model is based on COM, on Microsoft COM, the Component Object Model, which is deeply integrated into the Windows operating system and widely used as a technology for communicating, for the communication of applications that are running on Windows. And it can also be used by many scripting and programming languages. And that is very practical for us because in UDE, we do not need a proprietary scripting language, nor we are bound to a specific one. That means you can use any scripting language you like. Python is only an example for that. You can work with your existing knowledge and you can work with your preferred tools, and you don't need to learn a new syntax if you already know a scripting language. This image here shows a part of the UDE object model. As you can see, it consists of a set of objects. So these rectangulars are the objects. These are composed in a hierarchy. Each of the objects provide interfaces that give you access to almost all the debugger functions. Because we have here this hierarchical structure of the objects in the object model, all of your scripts must first access a top level or root object. From here, you can access the next lower objects in this hierarchy using functions that we provide in each object or also properties. to get a specific object in that hierarchy which provide the debugger functionality you want to use, you must query all objects in the beginning from the top object in the path to the requested object step by step. I show you that later, how it works. At the very top, we have two objects that are used as a starting point. The first one is so-called UDE launcher. That is used if you want to create a new UDE debugger instance. So yeah, basically to start the UDE. And then we have the UDE running instance manager, which is used to connect to an already running UDE. So from that, you get the UDE application object from where you can start to obtain all the other objects in the hierarchy and yeah, proceed in the path to the object with the debugger functionality you want to use. So the application object is the actual root object of the UDE object model. The launcher and the running instance manager is yeah, somehow outside of the object model. So this and all the subsequent objects provide the several debugger functions. There are a lot more, but yeah, to keep the picture simple, I have only the most important ones here shown. We have in all the objects get methods or properties that you can use to obtain the next objects in the hierarchy. And to illustrate that how it works, I have here this four-liner on the bottom, which is used to retrieve the debugger object of the first core of a connected device, for example, an AURIX, and to use that object, this debugger object, to start the application on your device. To do that, we firstly access the running instance manager to get the UDE application object. So we assume that we have already an UDE running on the PC. Then we ask the UDE application object for the workspace. So the workspace object contains everything that you have, for example, pre-configured for your debug session. And from the workspace, you ask for the core debugger for the first core of a multi-core system. And then you can use the go function to start the application. Each object implements methods or functions, as said before, and provides also properties. This is an excerpt of the documentation of the debugger object here. So you see on the left side the provided functions here, and on the right side the properties of the debugger objects. So the functions are for doing something, and the properties are to get or set something. This is a screenshot here, or two screenshots taken from our help system, so you can see that all of our objects in the object model, all the functions and also the properties are well documented. And you can click to a function or a property on this blue text to get more detailed information on how the definition looks like. This is given in a generic form. You see it here on the top, for example, for functions or methods, or here for the properties. And you get also an explanation of what is the reason for using this function, what are the parameters, and finally we have also on the bottom examples showing you how to use the specific function or the property in your scripting language of your choice. In our case, we want to look at the Python code. Okay, so it's now time to use the knowledge about the object model hierarchy and write our first script. And this is what we want to do right now. Before I switch to the UDE and an editor that I want to use is I'd want to introduce a little bit what we want to do with our script. We want to do a quick test for a simple application. The application runs on an Infineon Aurix and it implements a simple clock. So it counts seconds, minutes, and hours. And in our script, we want to test a specific function. This is the function which updates the seconds, and we want to test the wrap around when a minute is up. So we expect that the seconds are reset to 0 and the minutes should be incremented by 1. And that behavior we want to test. I use a Aurix microcontroller on a tri-board for executing the application. The tri-board is connected using the DAP debug interface to an UID2 Pro from our Universal Access device family, and that device is connected using USB to my PC. For the script development, I will use the Anaconda Python distribution and also the Visual Studio Code as an editor. For the Python distribution, you have to make sure that a special library is installed, namely Pywin 32, which allows us to access the COM in the Windows operating system. For writing the script using Visual Studio Code, we need also some additions to this editor. So they are named extensions, and I use Python and Pylons as the extensions for Visual Studio Code that needs to be installed before you can use Python in Studio Code. Because you have in Studio Code no Python interpreter, you have to set an external interpreter so that you can use Python from within Visual Studio Code. This is the hint how to do that. I assume that most of you are working already with Visual Studio Code, so you should be familiar with how to install extensions to that. As a sidekick, Visual Studio Code is not only good for writing code, but you can also use it for debugging, of Python code. This is very helpful for script development, but it's not. This topic is not covered in this webinar today. Instead, I want to use another nice feature or nice extension that you can also use with Visual Studio Code, which is JupyThor, a JupyThor notebook. That is an extension to allow writing Python scripts step by step and execute each step to see it work. So it's also a kind of debugging technology, but I'd like to use it to demonstrate how you can write a Python script for UDE step by step. Okay, then let's jump to UDE. I have already opened the debugger and also Visual Studio Code. And in the debugger, I load an already existing workspace. This is for the to demonstrate the first simple example. So I have already a workspace created. I load the application into the device, which is connected to my PC. I program the flash. These are manual steps. You can do this, of course, also automatically. I show you later how it works, but for the next few minutes, I work like that. So I have loaded the application. We can look at the functions here, and we can look at the function that we want to test. It is the update seconds function, which increments the seconds, and if a minute is up, it should reset the seconds, and also it's calling a update minutes function, which should increment the minutes as well. Okay, so we want to use this very small or simple example to illustrate how to create a script or how to work with the UDE object model. For that, I create a new file in our editor here. I create the Jupyter notebook file, and you see here some cells, or one cell which is initially created that allows you to type in some Python code. And for doing that, or for creating the script, the first thing is what you need to do is to load some libraries that you want to use. Mostly, or most important one is the Win32.com library, which handles the COM communication to the Windows system. Because we are using that to get the initial access to the UDE object model. To do that, we need our running instance manager, because we have already a running UDE here. To do so, we ask the Win32.com library by the dispatch function for the running instance manager, by its name. So it is registered in the Windows registry, and you can access it by its name. And then we check if we have already a UDE running on the device, and if not, we exit the script with an error message. But we are sure that we have. I have to execute, of course, the cells as well. So right now we have the running instance manager here in this variable, and we can use it to get the application object of UDE by using the get instance function and ask for the first instance. And to make sure that everything is running, I print out the UDE version that I'm using, which is the new UDE version 2025, which we want to release end of April or beginning of May. Okay, from that, now we have the UDE application object, which is the actual root object of the object model. And now we have to get the workspace. The workspace is also accessible using a property of the application object. And to illustrate that something is has to be done or is done, I print out the workspace file name or path, and we check also if we have a successful connection to the target device. With that, wait for target connected and a timeout value here. Okay, now we can start our application. To start the application, we need access to the core debugger of the first core of our AURIX. For that, we ask the workspace for the core debugger of core 0. If we will execute this, we have now in the variable core 0 the object of the core debugger of the first core, and then we can use the go function to start the application. So we see we have here the watch window opened and we see that our application is now running. We see it also here in the core indicators. After we have now a running function, we want to start our test. For that, it is very useful to stop the application when the update seconds function is entered. For that, we need a breakpoint, and the breakpoint breakpoints are a property of the core debugger. So we ask the core debugger for providing us the breakpoints object. This is this line here. And we can use the breakpoints object to set the breakpoint. One simple method is to provide the function on which you want to set the breakpoint, and then we wait that the application stops at the breakpoint. If we execute that, we see we have set the breakpoint at the very beginning of the function, and immediately the application hits the breakpoint and is now halted. Okay, then we want to write our test case. That means if you want to test the wraparound, we have to write seconds to 59 because this triggers the wraparound, and it is a good idea to have some initial value for the minutes. That is optional, but I decided to write the minutes to a value of 10. And this can be done using the debugger function write variable, typing the name of a global variable, and then you can provide the value that has to be written to the application. So we execute that. We see in the watch window we have seconds now written to 59 and minutes to 10. We can also read back this by using another method or another function of the debugger called read variable, and then you can print out that for our comparison later on, we store the minutes in a variable minutes before. We execute that, we have read seconds and minutes before with the values, and then we can optionally remove the breakpoint. The breakpoints have also methods to remove specific breakpoints by its name. We can also remove all breakpoints. I'll show you that later. And we set another breakpoint at the end by using the same function, but a little different breakpoint location string. This is the option to set the breakpoint at the update seconds functions and the 8th line of this function. If you count this 1, 2, 3, 4, 5, 6, 7, 8. That is the syntax of that. So we have executed that, and then we can proceed by using the the go function of our core debugger, wait for halt, of course. So we hit the breakpoint, and then we can read our values, our results, so namely the seconds and the minutes, using the read variable again, and then we compare seconds to 0 against 0, so for the reset of the seconds, and we compare also the minutes that we have just read with the minutes before +1. And if this is okay, so seconds are reset, minutes are 11, expected values, test has been passed. Okay, and then optionally we can clean up the breakpoints. So we remove all the breakpoints, start the application. That's an optional step. Not optional is to clean up all the obtained objects during the script execution. And this can be done using this code here. So we set all the objects that we have obtained during the script execution by assigning none to them, and then the Python interpreter will clean up the objects, and then you can safely close UDE. This can be done manually, and that's it. This was the first script, and I showed you how to connect in script to an existing UDE session. If you want to open a new UDE from your script and create a workspace, you can use the same script with minor changes. Firstly, instead of the running instance manager, you need to use the launcher. To get the launcher, quite the same as you got the UDE running instance manager. Once you have the launcher, then you can use, for example, the start and create workspace function to open UDE, create a new workspace with a given file, workspace file name, and with a provided target configuration file. So the target configuration file have to be exist already. It specifies which device you want to connect, which debug interface you want to use, and also which UID you want to use. The true parameter here tells the function that you want to create a workspace, even there is the same file already existing. Then we get access to the workspace, to the core debugger. In this specific case, we have no target application loaded because the workspace was created. So we need to load the target application into the debugger, and we have to program it also into the flash of the device. This can be done using a debugger function load and flash. And finally, we can, and after that, we can proceed with our test. And finally, we have to clean up everything, and we have to change the script a little bit as well for the cleanup, because we have a launcher. We can use the launcher to close the UDE, clean up the UDE application object, and clean up also the launcher object. And then you have done it. And to show you how it is working, I load the script, which is this one, which is doing the same test, but with starting the UDE. So we have all the steps to load the libraries, then we get the launcher. We need some variables providing the file names and the paths, and then we create the UDE. Unfortunately, it is started always in background here behind my slides, and then we can obtain the workspace, get the core debugger, then we load the application into the Flash. We can start running. So now it's running. Now we have loaded the application running, set a breakpoint, write the test values, we read back the test values. We remove the breakpoint and set a new one as before. We proceed to the end of the function. We read the result values. We get test has been passed. We remove all the breakpoints, start the application again, and then finally we clean up. And during the cleanup, we also close the UDE application. Okay, yeah, now you know the basics of how to script with UDE. Next, we will look at some of the user questions we got in the past about how to do certain things in UDE with Python. For that, I open the UDE again, load the workspace that we already used before. We load the application into the debugger, and we make sure using the verify button of the Flash tool that the binary on our device is the same as we have loaded into the debug tool into UDE. We verify that we have no differences. We can close that. Okay, that is the same application counting up our clock we are performing our clock. And then I open the Visual Studio Code again, and we create a new script. And the first thing, I keep it short. We do all the things that we did before in one cell here. So we get access to the UDE, we ask for the workspace, we ask for the debugger. I name it in this example debugger here instead of core 0 to keep it more simple. And then we start the application. So now we have a successful connection and the application is running. Okay, for the next examples, I'd like to test or work with a different function here in our application, which is called getQuarter. And at first, I'd like to show you getQuarter, which is typing in getQuarter here. There it is. It takes seconds as an input parameter, and then it decided in which quarter we are in a minute. So if the seconds are within the first 15 seconds, then we return quarter first. If we are between 15 and 30, we return quarter second, and so on. So we see the return value is of type quarter, which is a enum. Okay, and we have local variables here. So if you stop at the, if you go to the if you execute this and set the breakpoint, then we can start working with that function here in our script. I open the locals, that you see the local variables. So at the very beginning, the seconds and also the return value are not initialized properly because we are right on the beginning of our function. So the code for initializing the local variables are not executed. We can do this, of course, manually by using the step over button in UDE, but we can also do this in the script by using a debugger function step over. We do this twice because we need the execution of 2 lines here in our code to get also the red val initialized. So I execute this. You see this. We have now executed 2 lines, and second is initialized by the parameter, by the function parameter, and the return value is initialized to the item, the enum item quarter first. So we want to access local variables. So local variables can also be accessed by using, for example, read variable from the debugger object, but we need for local variables a prefix, the prefix at, so that the debugger knows this is a local variable. So we read back 32, and then we can write this variable by, okay, by a different one, maybe 14 or something like that. Read back, same syntax, using the at as a prefix for indicating that seconds is a local variable. Okay, so then we want to proceed to the end of the function here. For that, I could use the same syntax with the line offset as we used before, but I'd like to show you 2 possibilities to do this alternatively. First is to use an expression. So the expression is a very powerful object that can handle symbols of your application. Symbols are function names, variable names, and so on. And we can also calculate some values on the basis of expressions. For example, we can calculate the last address of a function by using the end of function here in our expression. We can use this expression then as an input value for the breakpoints and set with that the breakpoint to the very end. And to keep the script a little bit cleaner than before, we clean up the expression right now. Okay, so we executed that and we see we have set the breakpoint at the very end. This is the first method I'd like to show you. I remove the breakpoint. The second method is to use a different one on a different function provided by the debugger object, which is the get function return location, which gets the address of the return instruction of your function. And you can you get a new object function return location, and this object provides, for example, a set breakpoint function to set the breakpoint also at the very end of this function. And finally, we clean up also this object. Once we executed that, we set the breakpoint at the very end, and then we start the application again. We proceed to the end. And finally, we can use also the get variable for getting the results of our redwell enum, but we can also use expressions for that. So, and then we get more information. We have a value string property which provides us the name of the enum item, and the value, of course, provides the value of the enum item. If you want to get all the information or more information by script about, for example, this expression here, then you can get more information by using, for example, the type property. And we have also a symbols object that provides us more information about the enum. We can use this to iterate through all the items of the enum and print out all the information that we can get out of this redwell symbol here. So the redwell is of type quarter. This is that line, and the quarter has 4 items, which is that line here. And we can iterate through all the items of this enum and print out also the information about the name of the items and also the numeric values. Also for global functions, you can ask for all the global functions using the symbols object. We have a fixed address vars property for that. You can print out the global functions of your application. So you can you have access to all the symbols within your application also by using the script. Sometimes, completely different topic here. Sometimes users ask us why they are seeing not the output of a print in Python instantly when it was executed. This is the reason is the Python interpreter. And to overcome this, you can also use an internal mechanism in UDE to output some values or some text during the script execution. I open the console window here, which is now here, and we can output also as an alternative to print in Python using a function con output of the debugger object, for example, to print out the current value of redwell. And sometimes you will find it useful to output also into the message log. This can be also done by using a workspace property, which is called message log, which provides an object with, for example, a function called user or log user. And if you execute this, it will tell you that the webinar is now coming to an end. And what I forgot, the most important things, sorry for that, is of course to clean up everything as we have done already in the other examples. And that finally brings us to the end of this webinar, and I'd like to thank you for your attention.